Algebra 2, we're taking a look at lesson 10.11, which is actually a review from plane geometry or geometry and construction. First, one of the most famous triangles, right triangles, are the 30, 60, 90 right triangle. And the 30, 60, 90 right triangle has a very definite pattern. Opposite of 30, we'll call that x. Opposite of 90 is always 2x, and opposite of 60 is x radical 3. And you want to have that memorized. Opposite of 30 is x, opposite of 90 is 2x, and opposite of 60 is x radical 3. You'll always have that pattern. Now, for a 45-45 right triangle, which is really half of a square, opposite of 45 is x, opposite of this 45 is x, but opposite of the 90 is x times the square root of 2. So, if we were to take a look at problems like this, you can see we're going to have some problems like this in Alg2. Could we find the missing sides? Well, opposite of 30, we're always going to call that x. Opposite of 90, we're always going to call that 2x. And opposite of 60, we'll have x radical 3. Now, the wonderful thing is, you know what x is. X is equal to 12. So, 2 times 12 is 24. You just double whatever you have there. That's your hypotenuse. That's 2x. X radical 3, well, that's going to be 12 radical 3. And we are done. Now, if we were to come over here in this regard, again, remember, opposite of 30, we'll call that x. Opposite of 90, we'll call that 2x. And opposite of 60 is x radical 3. Well, here we have 2x is equal to 14. Let's solve for x. Let's divide by 2, and you will get x is equal to 7. That's what you're going to have here. Opposite of 30 is x, so you get 7. Opposite of 60, you can see right here, is actually x root 3. So what did we find for our x? Well, we found it to be 7. So that's 7 radical 3. All right, well, let's come over here. This might be the most complicated looking one of them all. Opposite of 30, we're going to call that x. Opposite of 90, we call that 2x. Ooh, opposite of 60 is x root 3. And it's right here where things can get a little intimidating. X radical 3 is equal to 9. We need to solve for x. And guys, when we solve for x, we could divide both sides by a radical 3, but we'd have to then rationalize, and we can do that if you'd like. But look, I'd like to introduce another way to do this. I'm going to multiply both sides by radical 3. And you might think, why in the world would you ever do that? Well, radical 3 times radical 3 is just a 3. Whenever you've got the same number inside of a square root, that number just comes out. So you have 3x is equal to 9 root 3. Then you divide by a 3. 9 over 3 is 3. So you get 3 root 3. And that's what you're going to have for x. So x is right here. You'd get 3 root 3. 2x would be doubling that. So if you were to take 3 root 3 times 2, only the numbers outside get doubled. You just multiply 2 times that 3 outside the radical, and there you go. You have 3 root 3 and 6 root 3. All right, let's take a look here at this next one for number 2. Opposite of 45 is x. Opposite of this 45 is an x. Opposite of 90 is x root 2. So they only want us to find this side right here. It's 3. Now, if they wanted us to find this missing side, and they will sometimes, if x is equal to 3, this hypotenuse here would be 3 root 2. Okay, let's take a look right here at this triangle. The 45, opposite of 45, will have x. Opposite of this 45 will have an x. Opposite of the 90 will have x root 2. And here we go. This is the equation that we're asked to really solve. This is what we're given. So I'm going to multiply both sides by root 2. You might wonder why. Well, because a radical 2 and a radical 2 together are just going to make a 2. Okay, a radical times a radical. As long as those numbers are the same inside the radical, they come out, they cancel out. So you have 2x is equal to 20 root 2. Then you divide by a 2, and you'll get 10 radical 2. So if they're asking for x up here, you'd get 10 radical 2. Right here would also be a 10 radical 2. Okay, so we've got one last set of problems to do, and they're actually mixed up a little bit. This is very typical of what you'll see in Alg2. You're going to be asked to just find one side. So opposite of 30, we're going to call that x. Opposite of 90 is 2x. And opposite of 60 is x radical 3. Well, look at this. You have 18 is equal to 2x, or 2x equals 18. Tell you what, I'm going to divide by 2 and get x is equal to 9. That means this side down here is 9, but see, I'm really looking just for one answer. I'm looking for this thing right here. By the way, that's x radical 3. So that's 9. If x is 9, you get 9 radical 3. Okay? Let's take a look at this next triangle right here. Opposite of 30 is x. Opposite of 90 is 2x. Opposite of 60 is x root 3. And here we go. Let me work up here. X root 3 is equal to 7. That's the side that I was given right here. That's really what I'm working with. So how do we start solving? Well, tell you what, I'm going to multiply the left side and the right side by radical 3. And root 3 times root 3 is just a 3. So I have a 3x. So 3x is equal to 7 radical 3. Then I'm going to divide by a 3. What's your x? Your x is 7 root 3 over 3. And guys, that's wonderful and nice. And the only thing is you've got to double that. Doubling is multiplying by 2 over 1. You see, you're looking for this big hypotenuse right here. So you're only going to multiply the 7 radical 3 by 2. Oh, it's only the top that gets multiplied by the 2, not the denominator. So this becomes 14 radical 3 over 3. Right? So when you double something, when you're doubling this, you're only going to double the top. All right, last one. Opposite of 45 is x. Opposite of this 45 is x. Opposite of 90 is x root 2. So look, I've got x root 2 is equal to 5. Tell you what, I'm going to multiply by root 2 here. I'm going to multiply by root 2 over here. Root 2 times root 2 is just a 2. And hey, look at that. And then I divide. So I'm going to have 5 radical 2 over 2. That's your x value. Guys, that's what you're asked to find. So you could just write 5 radical 2 over 2, and you are done.